Hey everyone, I'm Kaitlyn Barnard.
And I'm Victor Gamov.
In this series, we chat with software developers and technology leaders to tackle your biggest API connectivity challenges.
Stay tuned to this episode for tools, tactics, strategies that will help you to take your distributed architectures to the next level. Let's begin.
So today, I'm really excited to welcome Tim Hinrichs, co-founder and CTO of Styra. So Tim is here today to talk to us about implementing authorization for cloud-native apps. So Tim, could you just start us off by giving us a quick rundown of, authorization for cloud-native apps and how it relates to common connectivity challenges?
Sure. Well, first, thanks for having me, Kaitlyn. It should be fun. So authorization is one of those things that we've sort of seen and dealt with for decades, really. Remember, it feels good to actually mention what authorization actually means. So what I'm going to be talking about today is really this problem of controlling what people and what machines and what actions they can perform on software. So, we're talking about, if it's a banking application, can I withdraw money from an account? And I'll contrast that with authentication, which is something people sometimes confuse. And remember, authentication is just proving to the machine that you are who you say you are. So, typically you solve that with usernames and passwords. Today, we're going to be talking about authorization. So once the machine knows who you are, what actions can you perform? Withdrawing money from an account, closing it, opening it, whatever. So that's kind of what we're talking about today. And then especially we're going to be focused on, authorization in cloud native, which for me is super important because there's so much around cloud native that's making authorization more important than it ever was before. And to your point, how does that correspond to connectivity? Well, really the way we like to think about it is that the application in this modern era has sort of been broken into a bunch of different components. And obviously, those different components communicate through APIs, and you need to establish that kind of baseline connectivity. That's kind of what we always assume. We have to do some work to make it happen. But then once you have that connectivity, the next kind of question you need to answer is, well, the authorization problem, which is which of those services can communicate in which ways to which other services.
And I think that's a great place to start diving into this where, just the explosion of cloud native has introduce some new challenges here. Can you give us a quick rundown of, what those challenges are now when it comes to authorization?
Yeah. So one of the great things about this cloud native movement, this movement toward applications built out of microservices is that, you've broken, as I mentioned, all these applications that into a whole collection of components now that interact in interesting ways. And that makes it easier to build and deploy these applications more quickly than ever before. Which is, I think, one of the key draws to the entire cloud native movement. But what that also means is that now you've got far more pieces of software that are all having to communicate via APIs, right? In the old days, maybe you had a 3-tier architecture and you had a relatively small number of these components. In the new world, you have maybe hundreds of microservices, and they're all communicating over APIs. And so that new explosion of APIs means that there's more of a security problem, more of an authorization problem that needs to be solved there. And then if you sort of layer on top of that, the fact that all these services are so ephemeral, right? They may be spun up for a few seconds and then spun back down. So all of that sort of lends itself to a need for better security, more dynamic security, and tighter authorization all across the board.
Definitely. And so you're one of the creators of Open Policy Agent, or OPA. And OPA was created to essentially help address these challenges. So can you give us a quick intro of what OPA is?
Great question. So Open Policy Agent is a cloud-native policy engine. It was designed to solve authorization policy problems across the stack. So regardless whether you're talking about APIs or databases or cloud resources, all of those different areas, all those different domains have their own policy and authorization challenges. And so before OPA, every single one of those different products and projects had their own way of solving authorization. So the key idea behind OPA is to provide a single unified way of solving authorization policy across that stack. And so when I like to talk about OPA, I like to talk about really 4 things that it provides: a policy language, a file format that you can use to express policies, a policy engine where once you load it with some of those files, you can then ask it to make policy decisions for you. And then some basic tooling around helping you write policy, around debugging, authoring, and maybe profiling. And then finally, a bunch of community-driven integrations with OPA, so that there's something out there in the world that actually will enforce the policies that you put into OPA.
And one of the things we talk about in this cloud native world as well is kind of the flexibility and all of that. So can you talk about the different ways that you can deploy OPA?
OPA obviously has some pretty ambitious goals, provide one policy language for everything. And so it's flexible in a number of dimensions, one of which is sort of architectural deployment patterns that you can apply. There are a bunch of different ways you can do it. You can go ahead and take OPA and embed it as a library within, let's say, an application. You could run it as a sidecar. We see that a lot for like a microservice authorization use case where you've got 500 instances of your microservices, and you'll end up with 500 instances of OPA running right alongside all of them. You can deploy it as a daemon as well if you're not running sidecars. So you kind of reduce the footprint there. And then you can also use it as a building block for centralized service. We see that as well all over the place. So those are some of the key options that you have. And the kind of nice thing about OPA is that you can then take and use it to solve whatever architectural performance availability challenges that you have to meet the needs of your application.
Awesome. And, taking it back to authorization policies here, and you touched on this a little bit in the beginning. What kind of authorization policies can you write within OPA?
Great question. Yeah, it's a common one. And it's kind of surprising to some people that OPA can be used for so many different use cases for APIs and cloud resources and data, even CI/CD pipeline. So, in terms of the domain itself, you can really write a policy over anything you like. I will call out a couple of things, though, especially in the application space. A common question we get is, well, are we talking about service-to-service authorization? Which machines can run APIs or which other machines? Are we talking about end-user authorization? And the answer is yes, both. You can sort of again, because OPA was designed to be this sort of domain-agnostic policy engine that allows you to express whatever policies you like, whether you're writing policies that are conditioned on which machines, which services are performing or trying to run API calls, or which people are trying to run those API calls, OPA doesn't really care, and so you can even mix and match those. And then the other thing that I'll call out there is just that another common question we get in this space is like, is it role-based access control, attribute-based access control, or something else? And again, the answer is yes, both. In fact, OPA is expressive enough to do role-based or attribute-based access control. You can encode access control lists. You can encode IAM kind of policies that you'd see on the public cloud. So again, that's another dimension of flexibility that we see a lot of people like OPA for, because they can, at the end of the day, write the policies that they need to write.
Absolutely. And, when it comes to authorization, obviously this is a piece that's crucial for security. And it's definitely something you want to get right. I know we've seen this a lot, especially in the Kubernetes side of things. But are there any best practices you can share for writing these policies?
Yeah, best practices are good. I think one of the things that we see people do when they write policies well, we see a pattern emerge, and that pattern is pretty simple. You start with figuring out honestly what the English or whatever language you're speaking, what policies you actually want to write down and what policies you actually want to enforce. And it turns out that I don't know how many times I've been sitting in a meeting with someone who's trying to work this out, and they've got some big spreadsheet that says, here are all the cases that I want to cover, and here are the policies I want to write. And then you have several people at the meeting, and somebody says, oh, I don't really understand it. I don't really understand what we mean by this part of the spreadsheet. And so like just getting basic understanding of what policies you actually care to enforce is step one. And then so once they've worked out that, then step two is understanding sort of the schema for the data that you're going to be given in order to actually make decisions. So, whether you're talking about a gateway or service mesh or Kubernetes or anything, the way that OPA works is that it will go ahead and send over a big chunk of JSON that represents, an HTTP API or a Kubernetes resource or whatever it is. And so you need to understand what that schema is and where the information that you care about actually exists within the schema. So that's step two, is figuring out and understanding what that schema looks like. So now in step three, you're all ready to go ahead and write down your policy in Rego, which is the name of OPA's policy language. So anyway, that's the kind of best practice we see. When people follow those three steps, we see them be far more successful than when they don't.
Yeah, that's a fantastic advice. It's funny. It's one of those things I feel like we sometimes overcomplicate, but when you really break it down into steps like that, it seems so much more simpler. And one of the things we're seeing on the Kong side that I'm really interested here is a lot of companies aren't necessarily modernizing all of their applications all at once. So, with OPA, how can organizations adopt an authorization layer in situations where they, maybe have existing applications?
Yeah, this is good. This is a really interesting one to me because, as you say, there's so many people already have so many applications that aren't built in cloud native. How do they start, in slowly over time sort of pull in those applications so that they get some of the benefits of cloud native. So we see a couple of things that folks do. So one of which is that we see a number of maybe financial institutions more so than anybody have a bunch of pre-built, existing applications that are running on premise, and a lot of them are sort of dependent on an entitlement service, a service that, when asked, will go ahead and return all the entitlements for a particular user. And so one of the barriers for them just lift and shifting those applications into the cloud is that they have to also lift and shift. They have to have a cloud native implementation of that entitlement service. So that's one thing that we see people do is first they'll move that entitlement service over, implement it in OPA, and now they can actually move those applications into the cloud. But the next thing that we see people do is they say, okay, well, I also need now authorization security in place for my apps that are now running in the cloud. So they want to go ahead and put some of those rules and authorization policies into a gateway. And so now you've got, you sort of moved the perimeter. So each app now has its own little perimeter that you sort of enforce that at the gateway. And then what we see is a third step is they say, all right, well, now I'm pretty comfortable with this application. Now I can start actually breaking it into pieces, starting to use a service mesh. And so now when they embrace that service mesh, now they can take those policies, those authorization rules, and move them and enforce them, again, even closer to the back-end services or front-end services that they're using. So that's kind of how we see the progression from, and it doesn't always have, you don't always have to follow all those steps, but we see all three of those steps being employed by folks who are moving existing apps into the cloud.
Yeah, and this is kind of where that Kong piece comes into play. And we enable users within that connectivity layer via either that gateway or within a service mesh where that authorization layer can sit with OPA. And then the company you founded, which is Styra, which Kong is a partner of, helps extend that functionality of OPA to integrate directly with that Kong connectivity layer, as you mentioned. But can you tell us a little bit more about what Styra is building on top of OPA?
Yeah, so Styra aims to provide basically a management layer, a control plane, a single pane of glass to help you manage all the instances of OPA that exist out there in the world. So we kind of talked earlier about how architecturally flexible it is, and so that's kind of that's what people end up doing is they'll deploy not one instance of OPA or 5, but maybe 500. And so then there's a very clear question that needs to be answered, which is how do you write those policies? How do you test them, deploy them, et cetera, et cetera? And so that's where Styra's commercial product comes into play. One way that I like to think about it is that we aim to make this policy management problem and rolling out open to the enterprise much easier, both for individuals as well as for teams. And obviously there are different requirements for each of those. And the other thing I like to think about is that over time, one of the things that we do is that we learn a lot about how you solve service mesh authorization or gateway authorization or whatever, Kubernetes authorization, and we bake all that expertise that we've gained into the software, and so into our software. And so therefore, when you come in, you don't have to go and read nearly as many docs or understand quite as much about what's going on because the software sort of guides you down the path.
Awesome. Well, thank you for the fantastic overview of authorization, OPA, and Styra. I'm sure everyone's eager to see this in action. So maybe we can switch over to a demo now so folks can see Styra in action.
Well, one of the things that we talked about several times here was the idea at the end of the day behind OPA is that you can go ahead and use it to enforce policies across all your real world software systems in the cloud native space. So whether you're talking about a service mesh or a gateway, which, obviously we've integrated well with for because of our partnership here with Kong, but also for Kubernetes or any of the other cloud native ecosystem. And so what we see here on the left-hand side under this systems banner here is the list of real-world systems that we've connected OPA into, and that we're also therefore managing the policies for through the Styra DAS here. And so here we happen to have, 3 Kubernetes clusters. That's that little blue wheel icon. They're all at the top just because of the spelling here. You see some different service meshes. You see Terraform, Kong mesh. We'll obviously dig into here a little bit. But the idea at the end of the day is, we talk about a single pane of glass. So in the real world, what you'll end up with OPA is you've got a bunch of OPAs running. You've got some files somewhere stored in disk, often in Git. And so one of the things that we do just to make it super easy is, well, if you want to know what policies are enforced here on this Kong service mesh, you can just dig in through here and actually take a look at what policies are there. And so here what you see is sort of the OPA policy language. This is this text-based language for expressing policy. Here you've got a couple of allow statements that are allowing gets on a particular URL, and that's all fine and good. One of the things though that we'll do is that once you put this kind of policy in place, it's important to realize that OPA is now sort of making decisions all the time. Every API it gets, it's allowing it, denying it. OPA can actually also go ahead and make other kinds of decisions as well, which maybe I'll show you in a little bit. But here the idea is that you get to see this dashboard is showing all the decisions that OPA is making sort of over time. And this is obviously a demo, which is why there's so many flat lines here. But what you see here over time is all the decisions. Greens are allows and blues are denies. And then what's the latency as well. So all those things are important to be monitoring, whether you do it through DAS or otherwise, to make sure that that things are behaving the way you expect. All those decisions are things that OPA will also go ahead and log. So we can show that to you here. And this is pretty important as well, because when OPA goes ahead and makes a decision, that's all fine and good. But if an auditor comes along and says, hey, demonstrate. So sure, you said these policies are here. How do you demonstrate that they're actually doing what they're supposed to do? Well, here you can go ahead and dig through all those different policies. You can, as you can see here, they're also represented in what I like to call a high fidelity JSON log. And so you can go ahead and do, analytics over this log if you so desire. One of the other things that you can do here, we'll go back to the policies. So now that you've kind of seen both the first shot at the policy and you've seen sort of the decisions that get made over time, one of the things that you'll realize that even as an individual is that let's say we want to go ahead and make some change to the policy here. One of the things that you need to be careful of here is that if this is a production application, you want to be sure that you understand what the impact of this policy change is going to be before you go ahead and put it into production. And that's what that validate button is going to do over there. So here I've pulled out one of the rules in the policy. And so now, is that safe to do? How many of my past decisions are going to change? And that's what we're pulling up here on the right-hand side. So what we're doing is we're taking that log of decisions that we just showed, and we're rerunning that log using this new draft policy that we have available. And then what we're doing is we're flagging those decisions that were made differently by your draft policy. So let's say the old one was denied and now your new policy allows it, or vice versa. And then we're kind of surfacing those to you so that you can go ahead and kind of scroll through them and inspect them. At a high level, though, what I always take away is sort of like the percentage change that you kind of see. And this is like a sampling approach. So, but in this case, what we see is there's roughly it's right at a 25% change in your past decisions. Is that safe? That's probably pretty scary if you're going to suddenly start denying 25% of the decisions that you used to allow. But maybe if it's 1%, it's fine. Anyway, so this is one of the things that we try to focus on and that any OPA user should be thinking about is like, if you're going to make your policy change, how safe is that change to actually go ahead and deploy? So this is one of the things that we focus on. Another one is policy authoring. Here, there's some folks who would love nothing more than to write, crack open a text editor and write policy all day. Others want a little bit more guidance, and so there is a point and click way of doing that in the DAS. The other thing I'll point out here, I'll jump to another system, is that for some of these different system types, as we like to call them, Kubernetes, for example, we can go ahead and provide a whole bunch of pre-built rules. And so that's harder to do in a service mesh kind of setting, of course, because we don't know what the APIs are. So we can't very easily give you a bunch of pre-built rules. But for other sort of infrastructure use cases, you can see a bunch of pre-built rules. And here you kind of see yet another kind of interface for authoring policy, this sort of card view, where when you put a new rule in place, then maybe it goes ahead and allows you to parameterize that in some way, shape, or form. You can still look at the code if you want, but you can also use this card view. Okay, so that was kind of the most of what I wanted to cover. I will just say a couple of other things here quickly. One of which was that, one of the things that we see happen when you actually bring this into an enterprise is you start thinking about how do you work with larger teams in order to write policy. And so sometimes what we see people wanting to do is having one team, maybe it's a security team responsible for global policies that span maybe all the kube clusters or all the Kong mesh service meshes. And so that's what the stacks feature is for. The idea is that you can write some global policies there and then dictate that those policies must be applied to all the relevant systems that they apply to. And then there are other kinds of sharing too. That's what this libraries thing is for here. If you wanted to put in a library, common code that would allow you to ensure that all JOTs, all JSON web tokens are validated the same across all of your different Kong mesh instances, then you could go ahead and do that, maybe with a library or even with a stack if you so desired. The other thing that's important that I'll mention quickly is just that what we see, hopefully at this point, is that OPA and DAS sort of embrace this idea of policy as code. So all the policies that are written are, at the end of the day, represented in this text-based form. That's these other, card views and the policy builder view I showed you a little bit ago. It's just sort of a layer on top of that that makes it easier to write those policies. But because all the policies are written in code, what you can do is therefore store all these policies in Git. And so therefore this becomes, from a policy authoring point of view, yet another IDE. Different folks can choose to write, crack open VI if they want to write policy that way, or they can go ahead and do editing here.
Awesome. Thanks so much for the fantastic demo and letting us see that all in action. We will have links in the description of this video so that you can check out both OPA and Kuma. So those are both open source projects that are part of CNCF. And then we'll have links to check out both Styra and Kong Mesh, their enterprise counterparts. So Tim, any other final comments that you want to leave the audience with today?
I would just say, go check out Kong and Kuma, Kuma and OPA and Kong Mesh and Styra DAS. Styra DAS, I'll point out there you can sign up for free and check this all out. Quick starts. Sample apps, sample data, so it'll walk you right on through getting this set up and running.
Awesome. Fantastic. Well, it's been a pleasure talking with you today, Tim. Thank you so much for taking the time, and we will see you all next time. Thanks to everyone out there for watching. I hope you enjoyed today's episode as much as we enjoyed recording it. Make sure to hit that like button now.
And be sure to subscribe so you don't miss a new episode.
Don't forget to drop us a comment if you have any questions for today's guest or if there's a topic you'd like to see us cover in the future.
And we will see you on the next episode of Kongcast.